A very good morning and a warm welcome to all present. My name is Anmol Krishan Sachdeva, and today we are going to talk about how to have network immune system created for a multi-cluster mesh. My colleague was not able to join due to some unforeseen circumstances, but you should be in good hands. We'll have everything covered. Just a disclaimer before we get started that the content presented here should not be associated with any of the organizations that I'm part of or any professional bodies that I'm related to. This is personally my view. I'm a hobbyist, I do things, and generally I'm pretty active in open source, so these are based on my personal learnings. So I would like to start the talk with this, I would say, phrase, and that a pod, when compromised, is essentially not an incident, but it's something which should be lighting a spark. This is something which is very critical for multi-cluster meshes or any kind of hybrid connectivity setup that you have for your multiple clusters, your estate where your workloads are running. Because if there is any pod that gets compromised, there can be lateral movement to other clusters. You can have a very big blast radius and you don't know what the impact could be. So this is something with which we should be starting the talk, and our theme will revolve around network security throughout. Basically, we need to understand that there is a big latency gap that generally is observed when there is any attacker trying to mimic kind of an attack or even do regular attack. So generally the attacks will be so orchestrated and coordinated that they will take less than a second to be executed, and if lateral movement is to be done, still that lateral movement will happen in a jiffy of seconds. However, when it comes to the human response, this is where it should take a lot of minutes. Probably it will be taking up to an hour as well for the organizations where the processes have not been sorted out. There could be some specific processes that you might be following, like you could be having a SIEM solution which can be doing some preventive, detective, or mitigative actions. However, getting to a real-time mitigation or prevention of an attack is something that many sophisticated organizations also till date have not been able to sort out. So this brings us to a particular aspect, which is the immune system aspect. We really need for our cluster footprint some sort of immune system like our human body has. Generally, when, let's say, you are hit or stung by a bee, your reflex system will kick in. You will have some sort of antibodies also that will start fighting against, let's say, any viral infection if you are getting caught by something. So similarly, we need to have a system which should be having some autonomous reflexes, so that if anything is affecting the system or is trying to affect the system at scale, we should be having some sort of mitigative or preventive actions. And ultimately, nothing goes without a dose of vaccine shots. We all took that during the COVID era as well. So layered immunity and vaccination is something that also applies to systems. When we talk about layered immunity, this is where there are going to be layers in which we are going to apply some specific policies or configurations which will help us get safeguarded against such kind of attacks. And vaccination is generally to help prevent exposure and spread of the stuff, any kind of attack that is there to any of the pods or workloads that are prone but have not got affected yet. So we are trying to move away from passive conduits to something like an active defense system, and this is what the talk will be covering. So here we will be covering the anatomy of defense. We have three pillars that we have to cover. The first one is around the sensory system. The other is the controller system, which is the middle tier. And then we have the antibody system. So the first system that we talk about will be based on Tetragon. It will be having kernel level visibility, and it will be able to tap on the ancestry of parents or child processes. It will be able to check into how the process is working, how exactly it is trying to act with the system, what kind of probes are being attempted, etc. And similarly, the brain will actually be considering the context-aware, I would say, behavior, and it will be doing contextual analysis on top of whatever the workload that has got compromised is trying to do. And ultimately, the antibodies, which are nothing but Cilium policies that will help us have network and connectivity related policies enforced. We can even have protection at L3, L4, L7 level. So let's come to the first layer of defense, which is where the reflex system comes into picture. This is where we will be leveraging something called as the tracing policy that is available in Tetragon. This is where at a high level you can understand that if any specific signature is getting detected, then there will be some defined set of actions that will be performed based on what is defined in the policy. For example, let's say you have a particular binary which is trying to get executed, and you think that that particular binary is going to be malicious to your system. You go ahead and you block that particular binary. Likewise, if you want to have data exfiltration related issues mitigated, this is where such kind of policies come into action. And ultimately, we need to understand that the tracing policy is going to act in milliseconds level. So anything related to lock creation or having the packet floated, etc., to any of the systems, or any kind of alerting that you might have created in some webhook-based system, those things are not going to be triggered because the mitigation or the prevention will happen much before that kind of action will be taking place. So this is where we will be simulating this flow shortly. A second is the brain, wherein it really doesn't matter what you run, but it matters why you run. So let's say an attacker has found out the patterns and they have identified that you are denying, let's say, usage of wget or curl in your pods. They will be smart enough to go ahead and try to wrap that particular binary in some other form and then try to do data exfiltration or try to do some sort of malicious activity by wrapping and changing the name of the binary to something which probably you would have kept in your allow list. So this is where, let's say, if kubelet is going ahead and triggering a sleep command, should be treated as safe. But if, let's say, there is a shell that is trying to execute a sleep command, then probably you should scan it for further analysis, whether it's legitimate or whether it's malicious intent. And then the third one is about the quarantine. So this is where we will be having attackers generally trying to do repeated attacks in different shapes and forms. If at all you have actually got protection against the attacks using tracing policy or any of the native policies or network policies that you have enforced, or even like the protection that you might have enforced using regular Kubernetes custom resources like service account-based protection, security context, or role-based access control, all those things would be kept aside, and you should be trying to understand if repeated attempts of the same kind of attack through different versions of the attack are getting carried out. If so, then you should be labeling such kind of vulnerable workloads and doing some sort of quarantining so that you can mitigate or you probably can contain the spread of the attack to the other workloads. So this is where we will be having the blast radius contained. With this, we come to the high-level setup of how we think we will be having a whole of this particular scenario simulated for this demo purposes. So we have two clusters. It's a bit small. I'll read out. On the left-hand side, you have a cluster which is in US West region, and then on right-hand side, you have a cluster which is in US East region. I'll show that live as well when I go to terminal after this. Both of them are connected using Cilium cluster mesh, and we have made sure that the certificate authority is same for both the clusters so that they can have trust among themselves. We have also got some security components in cluster A, which is in West region. So we have got some Tetragon tracing policies. We have got a controller system, or the brain, which is the quarantine controller. We have also got the reflex policy. This reflex policy is nothing but a fancy version of the tracing policy only that we talked about. Some specific controls around our demo are laid out here. And then we have workloads. So we have a front-end application. This is nothing but for this demo, I'm treating it as a netshoot container, so nothing fancy. And then we have the backend application, which is running in US East. This front-end application ideally should be interacting with backend application, so we have a stub service here so that we can do a multi-cluster routing, and we have got an annotation for making sure that this particular service is discoverable in global fashion throughout the cluster mesh. So that's at a high level the setup that we have. Ultimately, you should be having front-end application accessed in order to access the backend application. You can assume that network policies, etc., are already applied. But ultimately, the front-end application is going to be the one which is going to act like a vulnerable spot where the attacker will be simulating attacks. So let's get to our network immune system demo. If anyone wants to follow the code alongside, this is the QR code you can scan. You'll get access to the GitHub repository that has whole of the code for the controller as well as the policies that we have defined. Okay. So at a high level, this particular repository is arranged in this manner that you will have all the YAML files present in manifest directory, and you have the quarantine controller code, which is nothing but a regular Python wrapper, I would say, which we have written. This is just for demonstration purposes. Ideally, at enterprise level, you would be having a SIEM system, source system, wherein you will be having such kind of log entries from Tetragon or underlying system scanners sent, and ultimately you will be taking actions, be it preventive, mitigative, or detective. And you do have a setup.sh. This is essentially for following along. So this README I have composed in a manner wherein first it is introducing you to what exactly we are trying to do in the demo, and then there is a user guide with all the prerequisites covered. So it's a self-service guide you can follow along, or probably you can just carry out this stuff on any cluster. I'm going to do demos on Google Cloud Platform, but it doesn't really matter. So here I have 2 pods which I have deployed. These are part of a deployment for front-end application. And I do have my Cilium cluster mesh working. So this I have already got. So my west cluster is called 00 and my east cluster is called 01. You can see that the cluster mesh has both the clusters connected and there are no certificate issues. Specifically, what I have done is I have got the controller, the quarantine controller deployed. First, I'll show you what quarantine controller exactly is doing, and then I'll get to how it is working in the cluster. So this quarantine controller, as I mentioned, is a simple Python wrapper. We have a list of allowed binaries here. So these are the binaries which will not be treated as malicious. And if you attempt to do any kind of, let's say, wrapper over these binaries, then we will be having the parent ancestry basically checked. So for that, we have the different variants of shell mentioned here. Depending on the OS or the container image that you are using, this could vary. And probably when you are doing stuff with Tetragon or you are preparing such kind of wrappers, you need to be aware of the operating system as well, because sometimes you have to work with uprobes and you have to know which specific library files and their respective paths are if you want to go deep into tracing policies. So I have done nothing fancy here, just created a route, which is Tetragon hook. This is where all the events which are going to be trapped by the Tetragon are going to be sent, and ultimately I'm going to have some behavior-driven logic basically defined here. The logic is simple here, that I check for ancestry, I check where the binary is from, whether it's from kubelet or whether it's from some other interactive shell. And then there are some specific conditions that I have created just for demonstration purposes. This is not production grade, so don't treat it that way. And ultimately, we are checking whether we already have got the deployment quarantined or whether it's not. If it's not and it's matching a condition in which a threat probably could be getting simulated in your system, then in that case, you go ahead and quarantine that particular pod or deployment. Right now, I'm working on pod level. And ultimately, this is the conditional logic, basically, which quarantines the pod. So it's pretty much adding a label to the pod wherever it thinks it should be quarantining. And there is a Cilium cluster-wide network policy that is looking for this particular label, which is quarantine equal to true, which is on line 107. And ultimately, whenever you see a pod which has this label, you go ahead and stop the ingress and egress. You can do a selective ingress egress as well. Probably you want to have only some specific target services reached out from the front-end pod, so you can have such kind of things. So where that Cilium network policy is defined is under the manifest folder if we go. So let's check the manifests. And here specifically vaccine YAML is the file we are looking at. So it's checking for quarantine equal to true. Ingress, it's at a blanket level blocking, but for egress, just to show, I have kept DNS open, but this is where you can have a bunch of combinations of different rules to allow ingress from some specific sources and allow egress to specific targets. And likewise, we have the controller YAML. This is pretty simple. We have some cluster roles created. These cluster roles are working for getting and patching the target pods for the front end, and essentially this deployment is just running the Python controller that we wrote. We just made sure that we are enforcing security context here and making sure that we are hardening this quarantine controller as well, because it should not act like an autoimmune disorder, let's say, wherein the controller itself gets stuck or probably is hit by some malicious activity. But you again can have some other policies at Tetragon level to prevent such kind of controllers from being compromised. And I'll show you the other stuff as well. So front end is pretty simple. As I mentioned, it's a netshoot container. So pretty simple, nothing fancy. In backend, it's again a regular Nginx container that is running. And I do have reflex.yaml. Reflex.yaml is something which I have not applied yet, but it's a simple sysexec call that is going to see whether in any shape or form you are using curl. It will go ahead and it will block that particular process. So you will see exit 137 as the status if at all you are going to have usage of curl being done from any pod. And this I have applied at cluster level. And ultimately, let's get to the working now. So what I've done to simulate the scenarios, I have already started the port forwarding because I want to show you how exactly I am forwarding the logs. I'm not using fluent bit, etc. for now. So I'm just forwarding the logs on a localhost 5000 port. So I'm going to tap on the Tetragon logs and I'm going to send them to this 5000 port. This 5000 port is actually open with the quarantine controller. Quarantine controller gets the log from Tetragon. Ultimately, the logs get screened for behavior and contextual analysis. And based on what quarantine controller says, the policy gets enforced. So this is the command that I'm using. Again, nothing fancy, just doing a -c, -f output of the logs from Tetragon, and I'm making sure that I'm hitting for each log line the quarantine controller so that the logs are routed. I don't have a sophisticated fluent bit system, but ideally you would be using some log management system or log routing system. So let me go ahead and start tailing the logs for my quarantine controller. As of now, probably you won't see any logs. I'll just try to have 4 scenarios covered. Those 4 scenarios are mentioned as part of the README. So first is we will just attempt a regular call wherein the front end will be trying to hit the backend service, and that should pass because there is nothing malicious in it. Then we are going to enforce the tracing policy because someone could just be doing data exfiltration attacks using the front end pod because it is allowing the curl. So we will see that ultimately when you have the tracing policy enforced, you are getting barred from hitting a curl command. Then we will try to have an evasion attack wherein we will wrap the curl binary into some other binary. And we will see that now the brain or the quarantine controller comes into action because the evasion attack is something that the tracing policy was not designed to control. So the different steps for reproducing the demo are laid out here, basically the scenarios. So you can follow along. So baseline health is something that we are going to try first. So I'm going to have the kubectl exec command, and this I'm going to try with a regular backend call. So basically my front-end pod is trying to do a curl for the backend call, and this should ideally succeed because there is no tracing policy deployed yet, and the quarantine controller is treating this call as a healthy call. So if you see, it's inspecting the parent chain ancestry arguments, etc., and it's checking whether the call from behavior perspective is good or not. If not, then it will do some mitigative actions. So let's go ahead and without the tracing policy itself, first try to simulate the case wherein you are trying to do data exfiltration. So I'm just trying to curl over, let's say, malicious.com, potentially shipping some data. So this is where you will see the label for the pod will change now one of the pods will turn to quarantine true, which has happened in real time, more or less. And this is where now you see that our quarantine controller has got the logs that there was some suspicious activity detected, and it has labeled the pod as quarantine. Now, if I go ahead and attempt, regardless of whether it's a legitimate target or illegitimate target, my pod should go into a hang state. I should not be allowed to do a curl, ideally. So it might take some time as well sometimes to have this particular thing registered, but as of now, you see that the curl got in a hang state, and I'm unable to proceed forward with any kind of curl activity. So this is where my ingress got blocked, and my egress is only allowed on the DNS that we discussed on. So for now, just to show you the tracing policy in action, I'll go ahead and I'll label the pod as not quarantine, so this label will get removed. I'm just manually removing this label for now. And we will go ahead and have the tracing policy applied. So this is reflex.yaml. So this will go ahead and have the tracing policy for making sure that there is no curl command getting allowed. So anytime you end up having curl command deployed, you will be having access forbidden, and you will be getting exit code 137. So I'm just applying this policy to my cluster. Let's wait for it to get applied. Okay, so it has got applied. So ideally, I can start trying to hit my regular backend, and ideally by now it should have got into action. So it's showing me 137. So tracing policy is actually helping us prevent any kind of execution of curl, even if you would have done this through a process internally, unless you would have done some, let's say, Python package level thing, and you would not have checked the libcurl library, etc., then this would have succeeded. But generally, for any usage of curl, regardless of whether it's through exec or whether it's part of the application itself, this will be getting blocked. And then now we have tracing policy in picture, but still we want to see what we can do beyond the tracing policy. So we will do a data evasion attack, and that will specifically be like this. So maybe I'll go ahead and copy the command from, I'll try to wrap up the curl command into a sleep command, and let's see what happens. So now, ideally, my quarantine controller should come into picture because the tracing policy is not able to go ahead and detect this. I ideally should be having the quarantine label appearing here. So one call got succeeded because it was the initial call, and sometimes it takes the controller to synchronize a bit. But now you see that the quarantined label has been shown in the logs, and you see evasion blocked. And now going forward, if I try to do such kind of evasion attacks, again, it should be getting into a curl hang. So basically, you have used tracing policy along with your own controller to make sure that the spread of such kind of data exfiltration or evasion attacks is not happening. It might take like a couple of seconds for it to sync, and after that, it will come to a hang state. So this is the demo, basically. So recapping the demo, just being conscious of time, we had the baseline health check done, wherein we did not apply any policies, neither the quarantine controller nor the tracing policy, and things worked fine. We were, in this case, able to perform data exfiltration attacks, etc. Then we had the reflex system, which is the tracing policy enacted, and this is where we had exit 137 code for any kind of curl usage that was happening in the pod, regardless of whether it was from exec or from within the application. Then we had the evasion command. This was where the quarantine controller logic came into picture because the tracing policy itself was not able to contain this attack. And ultimately, we blocked the lateral movement because we were able to quarantine the pod itself. So with this, I would like to wrap up by saying that we should not be chasing symptoms. We should be finding the infection, containing it, and then treating it. And Cilium, along with Tetragon, is a pretty good example of how this can be done. For people who want to see what else can be done or how you can see these things in action, you can even go ahead and have the Cilium Hubble UI This will open on 12,000 port localhost, and this will show you exactly which all traffic calls are getting blocked or which are getting dropped. It will also show you verdicts as to, okay, the policy got acted upon, and then there was a specific drop in the connection, or the connection was allowed or forwarded, etc. So you can see you have such kind of visualization also created, which are pretty intuitive and which help you understand from where the attack is probably happening and which all targets are getting safeguarded, etc. So such kind of things you can go ahead and check out. So yeah, feel free to share the feedback here. Thanks again for being a nice audience, and you can follow me by scanning this QR code, and the feedback for the session can be supplied at the top. Thank you, everyone.